You probably think AI started with Silicon Valley, with tech bros in Patagonia vests, training neural nets on giant datasets, building robots that can fold laundry, or at least almost fold laundry. But the real story, it's weirder, way weirder. It starts not with billionaires, but with Victorian mathematicians, pigeons trained to guide missiles, and one guy who believed he could simulate the human brain using nothing but vacuum tubes and logic gates. We're talking codebreakers who asked if machines could feel, psychologists who tried to teach robots emotions, a chatbot in the 60s that made people confess their problems like it was a therapist and scared its own inventor. Oh, and a summer workshop where a few nerdy scientists casually decided to name their new science artificial intelligence. They thought they'd solve it in 8 weeks. Spoiler, they did not. But what they did start is a story that keeps getting stranger the closer you look, because the origins of AI aren't just technical. They're philosophical, they're emotional, sometimes they're straight up tragic. And the punchline? We didn't just build smart machines, we built mirrors. It's the early 1800s. London is smoky, loud, and buzzing with the first jolts of the Industrial Revolution. Steam engines, gears, and gadgets are everywhere. And in the middle of this mechanical boom is a cranky genius named Charles Babbage. Babbage hated human error, like deeply. Especially in math tables, those long books full of calculations that powered everything from taxes to tides. So he starts sketching a machine. Not just a calculator, not just an abacus on steroids, but a full-blown thinking engine made of brass and gears. He called it the difference engine. It was the 1830s version of building a computer with spare parts from a watchmaker's shop. Now here's the twist. It was his friend, Ada Lovelace, who saw something even wilder. In 1843, Lovelace wasn't just a poet with a brain for math. She looked at Babbage's machine and imagined it doing more than numbers. She wrote about how it could compose music, process language, maybe even mimic creativity. And before electricity, before punch cards, before computers even existed. She called it poetical science. But even Ada, who had the imagination to dream all this, still said the machine couldn't truly think. It could manipulate symbols, sure, but it had no ideas of its own, no intentions, no soul. Still, what they sketched out on paper with 0 working parts was the blueprint for a programmable machine, a ghost of a computer, a century too early. And then, silence. The world wasn't ready. The funding dried up, the machines were never built. Ada died at 36. Babbage died bitter and broke, but their notebooks, those stayed. And one day, someone would blow the dust off. It's 1940. Europe is on fire. London's getting bombed nightly. And somewhere in the countryside, inside a mansion filled with mathematicians and coffee-fueled panic, Alan Turing is building a machine. Not just any machine. One that can break the Nazis' Enigma code. Turing's contraption, what we now call the bomb, wasn't elegant. It clunked. It clicked. It looked like something cobbled together from spare parts in a mad scientist's garage. But it worked. It cracked codes. It saved lives, possibly millions. And here's the twist. Turing wasn't just trying to win a war. He was chasing a question that had haunted him for years. Can machines think? He wasn't the only one asking weird questions. Across the ocean, a man named Norbert Wiener was watching anti-aircraft guns track planes automatically. He started wondering, what if machines could learn from feedback like humans? He called his theory cybernetics, a mashup of control systems, biology, and straight-up sci-fi. Together, these guys weren't building tools. They were laying down blueprints for mechanical minds. But Turing took it even further. In 1950, he publishes a paper titled Computing Machinery and Intelligence. In it, he proposes a test, a simple game. If a machine can hold a conversation so convincingly that a human can't tell it's a machine, then maybe, just maybe, it's intelligent. He called it the imitation game. And here's the part nobody talks about. Turing didn't think intelligence was about emotion or feeling or consciousness. He said, instead of asking can machines think, maybe we should ask, can they act as if they do? That question, it changed everything, but not in Turing's lifetime. He was persecuted for being gay, chemically castrated by his own government, and died under mysterious circumstances at 41. The machines he dreamed of were still decades away, but the seed was planted, and soon it would grow. The year is 1956. Rock and roll is brand new. Eisenhower's in the White House. And in the sleepy town of Hanover, New Hampshire, something bizarre is happening on a quiet college campus. Inside a lecture hall at Dartmouth College, a group of scientists, mathematicians, and engineers are huddled around chalkboards. They're not here to build rockets or talk physics. They're here to create artificial intelligence. This was the Dartmouth Summer Research Project on Artificial Intelligence, but everyone just calls it the Dartmouth Conference. It was the brainchild of John McCarthy, a 28-year-old math prodigy who, get this, coined the term artificial intelligence in the project proposal. He brought together legends in the making, Marvin Minsky, MIT's future AI guru Claude Shannon, the father of information theory Herbert Simon and Alan Newell, working on logic machines that could already solve math problems. Their plan: spend 8 weeks figuring out how to make machines reason, learn, and maybe even understand language. 8 weeks. They genuinely thought human-level intelligence was just a summer project away. The vibe? Part scientific summit, part science fiction writer's room. They argued, they theorized, they smoked a lot of cigarettes, and they dreamed out loud of thinking machines, robotic vision, computer learning, all in 1956. But here's the twist. They weren't wrong. They were just wildly early. They didn't have the hardware. They didn't have the data. But what they did have was a big idea. AI was no longer just a thought experiment. It had a name. It had a movement. And it had believers. And like all great origin stories, it began with a little too much confidence and just enough genius to change the world. So now we're in the 60s. AI has a name, a crew, and something even more dangerous: momentum. This was the first golden age of AI. Governments and universities start pouring money into labs. The buzz is electric. Newspapers run headlines like "Machines that think and will robots replace us?" Yes, that fear started early. And here's where the weird stuff kicks in. Meet Shakey. In a Stanford lab, they build the world's first general-purpose robot. His name? Shakey. He's about as tall as a trash can, moves like a toddler on roller skates, and takes minutes to decide how to cross a room. But Shakey could do something revolutionary. He could perceive the world, plan actions, and make decisions. Slowly, painfully, but still. In a way, Shakey was the first robot with a mind of its own, if that mind had the processing power of a sleepy toaster. Then there was Eliza. Built in 1966 by MIT's Joseph Weizenbaum, Eliza was a text-based chatbot that mimicked a Rogerian therapist. It asked questions like, "Tell me more about your mother." Simple stuff. No actual understanding. But something eerie happened. People got attached. They spilled their hearts to Eliza. They believed it understood them. Some even asked to talk to her in private. Weizenbaum? Horrified. He had built it to show how shallow a machine understanding really was. Instead, he watched people pour their emotions into a glorified script. He started questioning everything. What if machines could manipulate people? What if we wanted to believe they understood us? And in the background, expert systems rise. AI researchers start shifting towards something more structured. Expert systems could solve problems in narrow domains, like diagnosing diseases or planning factory schedules, using huge rule books written by human experts. It wasn't thinking, not really, but it looked smart. And in the 70s, that was enough to trigger a full-blown AI hype wave. The twist? Everyone thought general intelligence was right around the corner. Spoiler alert, it wasn't. By the late 70s, the optimism had turned delusional. People were predicting full-blown thinking machines by the year 2000, talking computers, self-driving cars, household robots that could do the dishes and understand sarcasm. And the problem? None of it was even close. The great letdown. Shakey couldn't scale. Eliza wasn't real intelligence. And those expert systems? They worked until they didn't. They were brittle. One bad input and the whole thing fell apart. Imagine asking a smart system about pneumonia and getting a logic error because the patient also had a cold. Not ideal. The media started turning on AI. Governments got impatient, investors pulled out. Suddenly, the labs that were booming, with funding and buzz, just went quiet. This was the AI winter. a deep freeze in research and interest that stretched through the 80s and into the 90s. The irony? The exact same people who once said, we'll have a machine intelligence in a decade, we're now being told, and you guys are basically doing science fiction. And just like that, AI went from the future to a punchline. And here's the twist, not everyone gave up. In dark corners of academia, a few researchers kept working, kept tinkering. They weren't chasing rules or mimicking logic anymore. They were watching babies. They were watching how humans learned, by seeing patterns, not by memorizing facts. And they started thinking, what if we tried teaching machines the same way? So it's the late 90s. The hype is gone. The money's gone. AI is basically a four-letter word in tech circles. But a small group of scientists? They're still at it. In particular, Geoffrey Hinton. He's in Canada, working on a fringe idea most people had already given up on, neural networks. These are systems inspired, loosely, by how the human brain works. Not rules, not logic trees, but layers of virtual neurons that could learn from data. It was clunky, slow, underwhelming, and for years no one took it seriously. But Hinton kept going. So did a handful of others. They were obsessed with the idea that instead of telling machines how to think, we should just let them learn. And then, something changed. Enter the GPU. Gamers of all people saved AI. Graphics processing units, GPUs, built for rendering explosions and zombie heads in video games, turned out to be perfect for training neural networks. Suddenly things that used to take days could be done in hours. And then came data. The internet exploded. YouTube, Wikipedia, millions of images, words, sounds, fuel for machine learning systems to feast on. Now those underdog neural networks, they started performing better than anything else. Voice recognition, image tagging, translation, neural nets were crushing the benchmarks. Quietly, methodically, and undeniably. The turning point? In 2012, Hinton's team entered a competition called ImageNet, designed to test how well computers could recognize objects in photos. Their system? A deep neural network named AlexNet. It destroyed the competition. Overnight, deep learning went from fringe to front page, and the AI winter? It was over. The machines weren't just back. They were learning fast. So here we are, the neural networks are working, the data is endless, the GPUs are humming. And suddenly, AI isn't just recognizing cats in photos, it's writing poems, it's holding conversations, it's painting surreal dreamscapes with one-line prompts. It's finishing your sentences before you even type them. This is where things get uncanny. Meet GPT. In 2018, OpenAI drops GPT-1, a smallish language model trained to predict the next word in a sentence. Then comes GPT-2, then GPT-3. And the world starts to notice. Suddenly, chatbots aren't stiff rule followers. They sound natural, sarcastic, poetic, even vulnerable. You give them a prompt, and they write screenplays. You ask a question, and they answer like they've read the whole internet. Sometimes they even make you laugh, or creep you out. And in 2022, OpenAI releases ChatGPT to the public, and just like that, millions of people start talking to machines every day. But here's the plot twist. These systems don't understand in the way we do. They don't feel. They just pattern match at scale, statistical echoes of humanity. And yet, the results? Freakishly human. The Imitation Game? Alan Turing's dream test from 1950? It's not science fiction anymore, it's Tuesday. We're not asking, can machines think? We're asking, and can we still tell if they're not? Because when you talk to a bot that can write songs about heartbreak or generate images of memories you never had, you're not just using a tool. You're talking to a mirror, and what it shows you is us. So let's rewind. A cranky Victorian builds a math machine out of gears. A poet imagines it writing music. A wartime genius breaks Nazi codes and wonders if machines can pretend to think. A group of overconfident scientists throw a summer camp and invent a whole new field. And then, after decades of hype, heartbreak, and winter, machines start to learn. And now, we carry Adundai Chohai in our pockets. We feed it prompts, watch it paint, listen to it sing. But here's the strange part. In chasing artificial intelligence, we ended up chasing something deeply human. Pattern, emotion, meaning. We didn't just try to replicate thinking. We tried to replicate ourselves. And in the process, something got lost. We stopped asking the hard questions, not can a machine write a poem, but what does it mean when it does? Not is this intelligence? But whose intelligence is it built on? Because these systems don't dream on their own. They dream with our words, our images, our pain, our brilliance. And maybe the weirdest part? They work. They work so well, we forget they're guessing, we forget they don't feel. We forget that this whole journey, every demo, every breakthrough, every uncanny moment, started not with circuits, but with people. People who imagined, feared, and built machines in their own image. So yeah, the story of AI, is weirder than you thought. But maybe the weirdest part? It was never just about the machines, it was always about us.